Hello and good morning from Norway. So now we are ready for Radiocrafts webinar on designing low power wireless with the technologies and solutions. So there are still some people popping in, I see, but we will start off gradually here, and then we will hopefully they will be able to catch up. My name is Ørjan Nottveit. I'm the R&D Director at Radiocrafts, and with me behind the scenes are Niklas Nytun, our Sales and Marketing Coordinator. Before we start, there's a couple of housekeeping rules I would just like to go through with you. First of all, this is planned to last for 30 minutes with a 10 to 15 minutes Q&A afterwards, depending on how many questions there are. Please introduce yourself in the chat window. It's just good for us to know who's listening and who's. But of course, it's optional to do that. Please also post your questions in the chat window, and we will then go through them in the Q&A session after the presentation itself. We will post a recorded version of the webinar on our website after the webinar if you want to go back and see it again, or if you want other colleagues or something to see it. So before going into the technologies and the details, the key is why is low power a key design goal? And that, of course, has to do with battery operated devices and the total cost of ownership. So that means if you're able to save current or save power, you can use smaller batteries, thereby reducing the cost of the batteries in the system. You also don't have to change the batteries that often, so the service cost regarding changing battery is drastically reduced. If you have to send somebody out to change battery every second month on some devices, that means that service cost is actually one of the highest cost of the entire product. So it's all about your business to making it more profitable with these wireless sensors. You have to get down the cost of the ownership. Also, you have the advantages like batteries can be shipped with freight or air freight, whilst large batteries have to be done by ground transport. But that's I guess a minor thing. But the total cost of ownership is the huge thing, and that's the reason why you want to keep your power down, to use smaller batteries, replace them more seldom, and make more money. So what influences power consumption? There are three kind of main things here that we'll look a bit more into, and that's it's the hardware or the silicon itself. It's the protocols that you're using, and here there are trade-offs all the time. You can trade off power for range. You can trade off power for reliability, among other things. And then it's also the application. What is it you're doing with this wireless device? What are you sensing? What you're measuring? What are you controlling? And how often do you do this? So also what the application does is also very much a trade-off versus power consumptions. Then there's a statement that everybody does, and that's why it's made huge here. Wireless IoT with 10 years battery lifetime. So if you look at the commercials, if you look at the hype around the different technologies, everybody state they can have 10 years battery lifetime. It's been said by so many so often that it doesn't make any sense anymore, to be honest. But there's often a star around the 10 years, and that is about what's the use cases. Let me take a couple of examples. If I just make a huge enough batteries and connect it to my cellular phone and don't use it, I can have my cellular mobile phone last for 10 years, but I'm not really using it, and I'm having a battery so that I can carry around. Another example, which is of course more realistic, is that narrowband IoT has said that, okay, we can make 10 years battery lifetime. And everybody's repeat that message all along. What is that based on? That's based on a calculation made by the the operators that they do 1 transmission per day. They use an ideal AA lithium battery, so it's quite a big battery, and it's and they don't consider the realistic battery. They take an ideal version of it, and they say that the current of these chips is, well, it's not the chips that they can sell today, but it's a chip that they think might be there in 5 years' time or something. So that means that they then have a calculation showing they have 10 years, and that's a true calculation. So the calculation itself is correct. But if you say with the same narrowband IoT that you want to send every 50 minutes with a realistic battery and the real chip that you can get off the market today, one AA battery might last 20 days. And that might leave the customer a bit disappointed if he thought it should last 10 years. So when it comes to battery lifetime, it's all about the example or the application or the use case that they've set up behind the calculations. So you shouldn't be fooled by that. So power consumption, what is it that drains battery from a wireless device? There are a couple of key factors that you should consider. One is the transmit current, which is normally the biggest one when the radio transmit, because that uses most power. Obviously, you also have the receive current in case you're listening all the time. Then you have something called a sleep current, and that means that normally these wireless devices, battery-operated devices, will sleep most of the time. So the question is also how much current does it use when it's sleeping? And then you have the processing current when you do whatever you're doing with the sensor, measuring some CO2 or controlling some lights or whatever you want to do, that processing current. As I mentioned, the transmit current is the current which normally contributes the most to the battery usage. And the transmit current is given not just by the current itself, but also how long the packets are. So you have to combine both the current and the packet length to get the real usage. So here I have a slide showing comparing several technologies that we have that you can use for wireless connections today. So here we have the TX current in column 3, and the time it takes to send 20 bytes of application data in column 2. And then you see the energy for a single transmission of a packet in the 4th column. And what you see that all these LP-WAN technologies, the long range technologies, which is supposed to be low power, they use from 26 to 88,000 milliamp milliseconds for one packet. If you go to look at the 868 MHz wireless M-Bus, which is a more short range or medium range type of technology, you are down to almost 1,000 less. When we look at Riot, which is our new IoT solutions, which is about to be launched, we see that we have about 200 times less energy to send one packet than these long-range technologies. So it is quite a big difference between the really low power devices, and also we can include BLE here as well, which is even shorter range technology, which also becomes in the range of 30 to 40 milliamp milliseconds. So these really low power devices, which are used in a short range, like BLE around a person or in a room, or Riot, which is used more in like a building or a facility, they are significantly much more energy friendly than the LP-WAN technologies. A second thing with transmit current is the high peak current, and that means that all batteries have limited ability to handle pulse current. A coin cell are limited to 20 milliamp. A AA is specified to be 150 milliamp. But realistically, you can't use that much either. So using a battery close to the max pulse gives significant voltage drop. So that means that you use these technologies mentioned above. You have to include normally supercap or EDLC or HLC in addition to the battery, which also will drain the battery. This also applies to the things like Sigfox and LoRaWAN. If we go back, because of the length of the packets. As you see in the middle here, if you do LoRaWAN or Sigfox, you're transmitting for over a second when you're doing only 20 bytes of data. And when you're transmitting more than a second, even though you transmit like 40, 50 milliamp, that is going to drain the battery a lot because of the length of the pulses. So you also need supercap for those. Receive current is not that high in contribution as the transmit current, but receive current normally is about reliability and quality of service. So that means it's about listen before talk, so that you can avoid collisions. It's about listening for acknowledgement, so you can get more reliability on your link. And LoRaWAN and Sigfox and also wireless M-Bus normally avoid two-way communication. That means that they do have technical support for it, but the operators and the manufacturers normally avoid it to save current, and to avoid the fact that if they have two-way communications and gateway which supplies thousands of devices, if you have two-way communication, acknowledgement to each of the devices will make the gateway, will reduce capacity in the gateway because it cannot listen at the same time as it transmits. As it transmits. NB-IoT spend much more time in RX than on the other technologies, simply because they need to synchronize with the network. They are a synchronous protocol, and that means they do listen a lot to make sure that they have the same time synchronization as the mobile network. So even though, show you this, even though NB-IoT here on the transmit side is actually better than Sigfox and LoRaWAN, because the high receive current and the synchronization makes them equally bad or worse in some cases than Sigfox and LoRaWAN. So then you have the transmit current and the receive current of the different technologies. But when you make a solution, you need to consider your application, and that is a key to gaining low power. And that is also, if you make a low power technologies and try to transfer video or transfer a lot of data all the time, then you will make the low power technologies not that much low power anymore. So you have to consider the amount of data you're sending and have to reduce that. Also, you have to compress your data. That means that you have to code it wisely. You cannot send a chatty text string considering thousands of bytes, for instance. You need to compress it. And you also need to send only when required. That means you have to have smart sensors. When do you have to send data? Do you have to send it all the time? So we'll talk a bit about some applications on that. For instance, if you have an application which monitors something every 10 seconds, like the CO2 level in a building, do you need to send data every 10 seconds? Are there any things which are reacting, ventilation systems that need to respond within 10 seconds? Or can you average over a minute and send every minute? How long? What's your regulation system that you need to control ventilation to get this down? So it's all about doing evaluation and computing at the end node to make sure that you don't send any unnecessary data. If you have a breakage detector for a window, you don't have to send every 10 seconds that window is not broken, window is not broken. It's simply a waste of bandwidth. Of course, you need to send like heartbeats telling the user that the device is operative, the battery is okay, maybe every 2 hours or something. And then you need to send when the window break. And this is all done by doing, it's the term called mist computing. It's often used on this, which is basically computing at the edge nodes or the leaf and on the outer edge of the network. Another smart sensor example is localization, for instance. And there, everybody who makes a localization service include the accelerometers in the design. So accelerometers detect movements. So basically, the intelligence we then put in is that, okay, if there's no movement in a device, you don't really need to update the position that often. And if your position isn't updated, or if position basically is the same, then you don't have to send your position that often. You don't have to send every second that I'm on the same position as 1 second ago. That's again a waste of bandwidth. So here there's a lot of different examples we could go through, but the main conclusion is that make the sensor smart, make the application smart, and only transmit data when you need to. So here's a bit summary of the trade-offs that we're looking into. One is range and current is a trade-off. So that means the physics are the same. If you want to transmit the packet 10 kilometers, it will take a lot more current than to transmit it 100 meters. So any hyped marketing will not make the difference in physics. Other one is reliability. If you want to have acknowledgement in packets, if you want to have retransmissions and these kind of things, it will also cost current consumption. And also functionality will drive current consumptions. How often do you want to send data? How much data do you want to send? How much processing can be done at the end node? Do you want to have two-way communication that you send and receive data? That also means that you will have, it will affect the current consumption. So let me go a bit through the different technologies then that both we offer and technologies that we do not offer, but it's all about the same. So what if I consider Sigfox? Sigfox is very good for range. So it is optimized for range. It is one packet requires actually quite a bit of data to send, so it's not that low power. Also, in Sigfox, each packet is typically transmitted 3 times. So that's what gives them some sort of reliability. Normally, acknowledgement and retransmissions are not used. So that means that your reliability comes from transmitting 3 times. Regarding functionality, they do limit the number of packets you can send, and also the number of bytes in each packet. So it's 12 bytes per packet. So the Sigfox by nature will limit the amount of data you send. So Sigfox is therefore good for sensors which need long range and transmit very few bytes of data. And for that, Sigfox is a very good solution. But if you need to transmit more data, or if you need, if you want to transmit more data, that means then Sigfox has a limitation. LoRaWAN is pretty much the same, even if it's a different technology. It's pretty much the same. It's also very good for long range. It gives a very nice range. They do offer acknowledgement in their system, but if you use a public LoRaWAN network, they typically recommend you not to use acknowledgement, from the base station, simply because, well, the base station will then not listen while it's sending. And also, if all the devices requires acknowledgement, the base station will actually transmit too much of the time and will not comply to CE regulations anymore. So it's a bit of a challenge there. And they also so normally LoRaWAN is used for one-way communication. Also, if you go down to the lowest data rate, you also have a very limited amount of data you can send. So it's basically it's very similar to Sigfox in those respects. Wireless MBUS 868, for instance, it's much more focused on power. It's built for water meters and gas meters, which are supposed to last 15 years on a real battery. So they have made sacrifices. So 868 wireless MBUS is not that huge range, and it also is normally, it has a two-way communication, but normally it is used with one-way communication in order to save battery. But they do have quite a bit of more data rate, so they can send a more complex packets, and they can send more often. For instance, water meters in TOC mode actually normally transmits every 10 seconds. So you have a very low latency and a lot of data you can push over. So that's the high functionality. So wireless MBUS 868 is more focused on low power than the other technologies that we mentioned. 169 MHz wireless MBUS is more comparing against Sigfox and LoRaWAN again. So it's more high range. It's giving more coverage, but it have higher transmit current and also much longer packets. So that means the power consumption goes significantly up. Also, you need the super cap to be able to handle the high peak current. So, and the data rate is also lower than 868. So it is, again, it's wireless MBUS or WISE also is more comparable to LoRaWAN and Sigfox in range, and also in reliability and functionality. They do normally transmit at 2.4 kilobit per second, so the data rate is normally more high than on Sigfox and LoRaWAN. Riot that we are launching these days is more in the medium range area, so it's more range than we have on wireless MBUS 868. In addition, but it is also very low power, very short packets and very low transmit currents. So it can operate, for instance, on coin cell battery. It is focused on reliability, so that means it has ACK and retrans on all packets, and it also has two-way communication with quite high data rates, so it offers quite a bit of functionality. But the overall power consumptions of Riot is significantly less than these other technologies. I think if you compare it to Sigfox and LoRaWAN at low data rates, I think it's about 200 times more power efficient than those. Narrowband IoT is of course from some seen as the golden, let's just say as the optimum solution for wide area low power networks. However, so it is built for very good range. They do transmit quite high current. It's I think they use typically 200 milliwatt when they transmit in what they give out on the RF. They do have acknowledgement and retransmissions and these things built in. So they are quite good in reliability and functionality. But in terms of low power, they are probably the highest or the worst of all, because they also have a huge receive current because the synchronization. And they have to use a super cap, which also drains the battery. So in total, you will end up with the worst battery lifetime on narrowband IoT devices. That does not mean narrowband IoT is a bad technology. I think it's a fantastic technology. However, it's not for all types of application. And that brings me to kind of the conclusion of this. I'm not saying that narrowband IoT or Sigfox or LoRaWAN are bad technologies. They're very good technologies, all of them, and they're made for their individual use cases. But there's not one solution for all use cases. You have to consider reliability. You have to consider how much data you want to send and how often do you need to send data. What's your range and coverage that you need? If in case you are doing it inside, you have your facilities and you want to monitor something within those buildings or areas, how much coverage do you really need? Can the application be smarter to reduce the data traffic? That's something you have to consider. What's the service interval? So how often can you change battery of the devices before that costs your business? Are these devices that can be left to charge every night? Then you can make a solution where you charge them every night. Then you don't. Then you can live with a more high current device. What's the size of your sensors? I'm kind of sometimes I see people thinking that they will do these glass breakage detectors and they use narrowband IoT. Well, narrowband IoT requires a AA battery, so how large will this chunk on your window be? So it's these kind of things you have to consider. Security you have to consider. Network operation and maintenance. Of course, having a Sigfox device is very low cost because Sigfox operate the network, so there's no cost in that area. But if you have your own local area network, that means you have to also control the devices in that network. So one of the things that I think is very interesting is to use hybrid networks because of all these consideration that you don't get one solution to fit all. That means you could foresee other technologies like having a narrowband IoT device and then using that as like a gateway for more low power technologies like BLE if it's very short range, or Riot, which is more hundreds of meters of range. That means you get the service from the narrowband IoT device. You get your subscription there, but you have one subscription instead of 10. But they will maintain that connection where you buy your subscription from. And then you also can take advantage of using these maybe 10 or 15 sensors on the right side, which then can be coin cell batteries, changing batteries every 2 years. And so you get a very good total cost of ownership of the whole solution, having one device which is have a subscription and having 15 devices which are low power and you don't do anything with them. And they can then be very small batteries and again, very low total cost of ownership. So trying to sum up, since it's 30 minutes is gone. Again, all the technologies I mentioned here are very good technologies. There are no one solution that fits all. If you want to report if a door has been opened or not within 24 hours and you want to report that, which is basically 1 bit of information every 24 hours, probably that would make any technologies can be used for that. If you're transferring a lot of data within your facilities, for instance, and you have 15 to 20 sensors in a building doing a building monitoring the air quality in a building, having a lot of these LPWAN will cost you a lot in subscriptions, and they're not really optimum in terms of power. So consider your application, consider the coverage, consider the data amount you have to send and how often do you need to send it, and select the best solution for your application. And also, you need to design your application to be smart and do miscomputing. And then when you have done that, you can compute and verify your battery lifetime, and then you will see the results for your application. Okay, that brings me to the end, and there's not been too many questions. I see one from John Fitzpatrick asking if we have a LoRa module. No, at the moment we do not have a LoRa module. We have a Sigfox module, we have a 868 and 169 MHz wireless MBUS modules, and we are also bringing out the Riot modules. So we do not have a LoRa module. So if you have any, we are kind of it's something we are considering, as it is in our scope of what we normally could do, but at the moment we do not have an offering for that. Let me scroll down the chat window to see if there has been any other questions. Oh, sorry. Yeah, there were not too many questions today, so I will leave it open just a couple of more, one more minute to see if anybody else is having a question they're writing, and then after that we will end it. Yeah, I'm not sure what more to say. I guess I can start to summarize and say thank you for attending this this webinar. I hope you have learned something, and if it's one message that I want you to bring from this is that it is not one solution. It's not one solution that fits all, and also it's all this long range low power wireless they are low power, but they are not as low power as you can get with a shorter range radio. The Riot is, I see a question from Christoph asking, is the Riot standard open? Is it possible to reach out to documentation? The Riot is offering from Radiocrafts, so that is not a standard per se. The Riot solution we offer is based upon the IEEE 802.15.4G and E standard. So those are open standards. So on the pure pack on the bottom layers, we are basing on those standards, and then we have made some enhancement in the open in the upper layer regarding the application development, the reliability, encryptions and stuff like that on top of that standard. So that is our Riot solutions. It is quite a bit of information on it on the web, and there will be more within the few next 2 weeks. So just follow our website, and I think you will find the information you need there. Yes, then I will close this, and I would like to thank you for your attention, and hopefully you will be back for our next webinar, which will be in a month or so. Okay, thank you very much, and goodbye.